Most conventional heat pump systems transfer thermal energy through an indirect coil inside the hot water cylinder. The heat travels through the water in the system loop, which also circulates around the rest of the central heating system. A probe inside the cylinder measures the hot water temperature, and whenever this drops below the set point, the heat pump starts transferring energy to the coil. Most systems will prioritize the hot water cylinder by switching the diverter valve to cool for heat. For the system to work effectively, the hot water cylinder needs a very large coil to get as much surface area as possible between the coil and water stored inside. This is so the thermal energy can travel easily, with little resistance, keeping the temperature of the system loop as low as possible. When the system loop temperature is low, the efficiency, or COP, of the heat pump is at its best. Households usually use about half of the capacity of a hot water cylinder each day. So, by the end of the day, the top of the hot water cylinder might be around 50 degrees. The temperature in the rest of the cylinder drops considerably, to around 10 to 20 degrees Celsius, depending on the time of year. With about half of the cylinder coil in hot water, the heat energy is mainly transferred through the lower section of the coil, which is now immersed in colder water. Heat energy moves less easily through the hotter part of the coil, because the temperature of the water in that area of the cylinder is already high, so it is effectively locked out. As the heat pump tries to heat the water in this partially heated state, the system loop temperature has to increase, reducing the overall COP of the system. So, to summarize: 1. A large coil delivers good performance when heating the cylinder for the first time from cold. 2. However, when reheating a partially heated cylinder, the overall COP, or efficiency, is worse. 3. Some heat pumps slow down the heating when they detect this high thermal resistance, but this makes the heating process slower and risks causing comfort issues on a cold day. At Mixergy, we do things differently. Instead of having a coil inside the cylinder, we have a heat transfer module and heat pump control interface. The heat transfer module comprises a plate heat exchanger and circulation pump. This allows us to transfer energy from the bottom of the cylinder to the system loop. The heat pump interface works with the heat pump's temperature probe to determine when to heat the cylinder, based on the hot water schedule programmed through the Mixergy app. When heating a Mixergy cylinder, we take heat energy from the system loop via one side of the plate heat exchanger, whilst pulling cold water from the bottom of the cylinder through the other side of the plate heat exchanger. The advantage of this is that we achieve forced convection on both sides of our heat transfer surface, allowing us to achieve a low thermal resistance. This is different to a coil, where you have forced convection on the inside, but only natural convection on the outside, which is not as effective. The advantages of plate heat exchangers increase further when heating up a cylinder that's already partially heated. As before, about half the hot water in the cylinder is used throughout the day. When reheating through the plate heat exchanger, however, we are always transferring energy from the coldest part of the cylinder. This means that we avoid the problems of coil lockout and continue heating with the best possible COP. Mixergy's approach to heating with heat pump delivers 1. Enhanced heat transfer to obtain the best COP at all times, irrespective of how hot the water is in the cylinder. 2. The complete volume of the cylinder can be heated, meaning more litres of hot water from the same footprint. 3. Mixergy's unique sensing arrangement, controls and app mean you get visibility of how much hot water you have at all times. 4. Using the app, you can take advantage of smart tariff integration. 5. Installing a Mixergy cylinder now means your heating system is future-proofed, as the heat pump plate heat exchanger can be retrofitted at a later date. At Mixergy, we're always looking at options that provide our customers with the best solution for their individual needs. If you'd like to find out more, please visit our website, mixergy.co.uk.